And there we go. Good. Somebody read where it says number 1. Jerry.
Cut out each graph on the following pages, then analyze each graph. Make it to a scenario and tape it next to the scenario it matches. For each graph, label the x and y axis with your approximate quantity and unit of measurement. Then write the title of the problem situation on each graph.
Okay, so 8th graders, these we cut out already. They were on page, what was that, 11 and 13. So you should, you may need to pause if you haven't done that and spend a little time cutting out some graphs. You should end up with 8 little graphs, okay? One thing to notice in our little graph over here, we're going to be finding which graph fits some of the things we were talking about before, like baton twirling and the jelly bean challenge. One thing we're going to need to do on the graphs, if you notice, they don't have these words, time and temperature. And the other thing that we're going to need to do on these graphs is put units. So temperature was getting measured in degrees Fahrenheit, and time is getting measured in minutes. So we need to identify which graph goes with which scenario, figure out which axes is which, and put the units. And I'll give you a hint. Bottom axis is the independent quantity. Okay, so we've already gone through scenarios and identified dependent and independent. We might need to switch a couple based on the way the patterns in the graphs show up. But independent quantity, dependent quantity. All right? So, take your pieces and lay them on out. I'm gonna. They're all scrambled right now. We're not sure which one's gonna go where. Let's get all 4 out in front of us. In your books, flip backwards to page 5. Yeah, and it looks like you might need a little room, so if you need to put your homework on the floor or figuring it out. Okay, I've got all these graphs. I've turned to page 5 in my book. And I'm looking at the scenario, something fishy. I don't know today. Looks like it'll be a quiet day over in that corner, okay? Some days it's good to leave it that way. Here we go. Into something fishy. Let's remind ourselves. Tony, could you read about Candace?
Candace is a local manager for the Chelsea Enterprise office building. One of her responsibilities is cleaning the office building 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute.
Okay, so look at what we've identified for dependent and independent variables. Independent is time and dependent is water. So she's draining water out of the tank. If the dependent quantity is water, what will the level be at the beginning? High or low? High, and then it's draining at a constant rate, so that's different than the cooling of the tea. we saw or hypothesized that cooling of the tea would happen where it kind of leveled out and slowed down, but constant rate should be a straight line. Every single minute it goes down the same amount of water. So we need a graph where something starts high and goes straight down. Does it ever go back up? Not until after this scenario's over and she's done cleaning and puts water back in. But we're just talking about the draining. So it's only going to go down, and it's going to start high and then go down. Do you have a graph in one of these that looks like it might be something fishy, represent something fishy? Oh, I see it over there. I've got it in my hand. Who's found it? Well, let's see. Ding, 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 ding. This is what I'm seeing. H. And we're supposed to tape it on, but it doesn't fit. That's stinky. I guess you just kind of have to put it over the top of where it's talking about Candace, all right? So you have a glue stick in your little container. Yeah, we're going to need to write on the bottom. Yeah, we could do that. I guess maybe you could just barely fit it in, depending. There's more glue sticks on the counter. Yeah, sometimes this is better than that.
Okay.
Okay, we've got it glued down. That was part of our mission. We fixed the graph, we glued it down. Now we need to label the axes. Now this one also has time for an independent variable. That's along the bottom.
Hands.
Thank you.
There's some hands up for you.
Yeah, because the screen went off, I think. All right, we're labeling the bottom time because that's the independent variable. And we're showing that we're measuring it in minutes. So, Andy, you guys are going ahead. Got the graph down. Time in minutes. The y-axis up and down is water, measured in gallons. Okay, let's take a look at smartphone. Chris V, could you read about smartphones, please?
You have had your eyes on an upgraded smartphone. However, you currently do not have the money to purchase it. Your cousin will provide the funding as long as you pay the interest. He tells you that you only need to pay $1 in interest initially. And then the interest will double each week after that interest. Do you consider this offer and wonder if it's really a good deal?
Okay, so we had independent quantities of time and a dependent quantity of interest, or the money. So first of all, at the beginning, is the amount of money you are owing your cousin high or low? Low. And then the longer you go, the way interest works, if you leave it in for, I don't know what time, 1 week, is it doubling each week? It's going to be a certain amount, then it's going to double. And then, so that's 2 weeks. 3 weeks, it's going to double again. All right, so it's going to start low and go up this time. We're going to look for a graph that does that. It also, where before it said constant rate, think of this. If I have $1 the first week and that doubles, what's that? 2. Then I double that, and what do I have? And then I double that, and then what do I have? That's not going to look like a constant rate on a graph. Okay? Here's 1, here's 2, here's 4, here's 8. Okay? Because it's doubling, what comes after 8?
16.
It's going to go start slow and go up quick. It's kind of opposite of cooling tea. Oh, people already found it. There we go. What graph do we have?
B.
Find your B, glue it down. Okay. Smartphone. Okay. Myra, what's going to be along the bottom? Time. The dependent quantity goes along the bottom. This time, time's being measured in weeks. The interest or money is going along the y-axis, measured in dollars. Now, when you flip the page, there are 4. We have 6 graphs left because there are 2 more on the next page. We're going to divide up these 4, though. Oh, but we have 6 tables. Maybe we should divide up all 6. You like that plan? Some are harder than others, though.
Do we have a hard one?
Let's see. Well, the jelly bean challenge, we didn't even. You want a hard one? Okay. We'll divide them all up 6 then. I think we're gonna pause these guys.